All right, so I have been given a proof, and I have been asked to prove that AC bisects DB. So let's look at what I've been given. I have been given that ABCD, this whole thing right here, is a rectangle with diagonals AC and DB. Okay? So what I'm going to do is, as with any proof that I do, the first thing that I should always do is write down what I was given. So I was given that ABCD is a rectangle. Okay. And that was given. So because it's a rectangle, I also know that it's a parallelogram, and that allows me to basically prove some things. That allows me to say that DA and CB are the same, and that DC and AB are the same. So number 2 is I'm going to say that DC is equal to AB. I'm going to go mark that up over here on my picture. And I'm going to say that DA is equal to CB. I'm going to mark that up on my picture. Okay. All right. So the justification for that is definition of a rectangle. All right, so now I need to look at what else that I can prove. Well, let's see. I can also prove that this angle is congruent to this angle, and that this angle is congruent to that angle. Okay, so I'm going to say that angle DEA is congruent to angle CEB, and angle DEC is congruent to AEB. And I can say that according to vertical angles. All right, so far I have got I've got one congruent side, and I've got one congruent angle. All right, so what I need to do is I still need to prove that this and this are congruent, and that this and this are congruent. So I know that there's side, angle, side, but I don't see myself really getting another side out of this, since that's what I'm trying to prove. So my best shot is to go for angles. So I know that DC is parallel to AB. And I know that by definition of a rectangle, because the definition of a rectangle says that it's a parallelogram where opposite sides are congruent and opposite sides are also parallel. So by being able to say that they are parallel, that allows me to say that this angle is congruent to this one. All right, so that allows me to say that angle DAE is congruent to angle BCE. And I can do that by alternate interior. All right, I'm really, really close. All right, so now my next step is to say that triangle ADE is congruent to triangle CBE. Okay, and I can say that by angle side. All right, so now by angle side, if I am saying that these two triangles are congruent, then I am also saying that this is congruent to this, and that this is congruent to this. So that's where my congruent parts come in. So I'm saying that AE is congruent to EC, and that DE is congruent to EB. And remember that for congruent parts, we can say congruent parts of congruent triangles are congruent. We can just write CPCTC. Okay? All right, so close to being done. Okay? So now, because we can say that they are congruent, we can say that AC bisects DB by definition of a bisector.